This video is going to explain how to do a Lewis dot structure of a covalent bond based upon the octet rule. This is on page 10 in your bonding and nomenclature packet. So this is only going to deal with covalent compounds. Covalent compounds are the only ones that are going to use this method. They're the ones that are held together by a sharing of electrons, not by an electrical attraction, which would be a plus to a minus. There are no plus to minus attractions in these. We could have a single bond, which is where two electrons would be shared. Each atom would maybe put in one electron to form that bond. Or a double bond, I'm going to go ahead and write this down here. A double bond would be four shared electrons, where maybe each atom put two in for a total of four. And then a triple bond would be six shared electrons. So there's a pretty complicated process to figure out the Lewis structure for ones that aren't easy, like we did that activity with the dot diagrams and you overlapped them, and so you could sort of look at these and see who could share. But sometimes they're a little bit more complicated than that, and that's where this process comes in. We call it the full valence shared method, FVS for short. When they talk about full, they're saying when you look at that atom and you look at its dot diagram, how many electrons would it need to be full? And for everything below this line, that number for this process is going to be 8. Anything above the line, full is 2. Anything below the line, full is 8. Now there are some exceptions to that. We'll get into just a few of those exceptions, but when you take college chemistry, you'll learn even more exceptions. So basically what we do is we look at the elements that are in the compound and say, are you above the line or below the line? For most of the time, that's going to be 8. But if we're dealing with hydrogen, it's above the line, so we would say it only gets 2. So as I go through these steps, I'm going to work this middle example out, the CH4 example. So if we're going to look at the full electrons for CH4, C is below the line. Okay, C is below the line right here. It's one of the ones that would be full with 8, but the H's are above the line, so they're going to be full with only 2. So what we would do is we would say 8 plus, and then there are 4 hydrogens in this compound, and to be full, they would each have 2. So we use PEMDAS. 2 times 4 is 8, plus another 8 makes this step have a value of 16. Okay, let's see what the next step is. Step 2 is V for valence, and that's where we're going to look at the available valence electrons by adding all the ones up for these atoms. That's where this dot diagram periodic table comes in. So carbon has 4 valence electrons, and hydrogen has 1 valence electron. So we would say carbon's first, it has 4 valence electrons, plus we have 4 hydrogens, and each of them has 1 valence electron. So 4 times 1 is 4, plus another 4, so this step has a value of 8. The third step is shared, S for shared. What we do is we're going to subtract these two numbers. We're going to subtract the valence from the full. So we're going to say 16 minus 8, and we get 8 for our shared step, but this step has a little bit more to it. A bond is made up of 2 electrons, so this is the number of electrons that these atoms are going to share, but to find out how many bonds that is, we're going to divide this number by 2, so divide it by 2, and we get 4, and that tells us how many bonds we're going to have. We're going to have 4 bonds. So to draw the molecule, we would put the least electronegative atom in the center, but there are some exceptions. Hydrogen can never go in the center. So for this one, since we have only carbon and hydrogen, carbon is going to have to go in the center. And then we're going to have 4 H's, and we're just going to place them around the carbon. And then each one of the bonds needs to connect the atoms to each other. And we're going to be connecting the hydrogens to the carbon, not to each other. And then if we had any extra electrons left over, then we would put those as dots, and I'll show you that in a second. So we'll go from this hydrogen to this carbon is one of our bonds. From this one to this one is a second bond. Here to here is our third bond. Then here's our fourth bond. So to check to see if we needed to put any lone pairs, we have to do a little bit more math. We see that we had 8 valence electrons to work with. When we look at the shared step, they had to share 8 valence electrons. So if the valence is equal to the shared number, there are no lone pairs. all of those valence electrons have been put into bonds. The last thing we have to do is check to make sure that each of these atoms has an octet, or at least how many they wanted to be full. We have to go back and make sure they have access to either 2 or 8 depending on who they are. So if each bond is 2 electrons, then this hydrogen has 2 electrons. So does this one, and this one, and this one. So all the hydrogens are fine. The carbon in the middle is making 1, 2, 3, 4 bonds. So that's 2, 4, 6, 8 electrons. So it's also full, and so it's fine. So we would call this one done.